Good evening and welcome to the Royal Academy of Engineering. My name is Robert Mayer. I'm Senior Vice President of the Academy, and I'm also Professor of Engineering at Cambridge. And it's my pleasure to be chairing this evening's lecture. Before we start, can I make the usual requests to ask you to switch off your mobile phones and to be aware of the emergency exits should anything untoward happen. This lecture this evening is the fourth in the Prime Innovator lecture series, and we're very fortunate to have Tristram Carfrae as our lecturer. He read engineering at Cambridge, and he's an internationally leading structural engineer, a principal and Arup fellow. He's collaborated with many of the world's leading architects, and was a recipient of the prestigious MacRobert Award for his work on the design of the water cube for the 2008 Beijing Olympics. And I think we're going to hear a bit more about that in Tristram's lecture this evening. In 2006, he was appointed as a Royal Designer for Industry by the Royal Society of Arts in recognition of his many achievements in engineering design. He's also named as one of Australia's top 100 of the most influential engineers. He's a Fellow of the Australian Academy of Technological Sciences and Engineering. So it gives me great pleasure, particular pleasure as a civil engineer, to invite Tristram to deliver his lecture on encouraging innovative engineering. Tristram.
Thank you, Robert, for that kind introduction. And ladies and gentlemen, thank you all for coming. For me, it is an incredible honour to be invited here to address you in London. I normally reside in Sydney, as you may have gathered. And to come all this way and find so many people wanting to come and hear me talk makes me think that Arup has managed to rig the whole guest list, which is probably correct. So I'm going to talk a little bit about the context and need for innovation, a little bit about how firms or organisations might establish themselves in a way that encourages innovation. I will be talking about one project this evening, the water cube. Then about my approach to design, which I think is sort of, for me, design, creativity, innovation are fairly well mixed. I'm not an academic, I'm not very accurate, I'm a pragmatist, a practitioner, if you will. I design stuff. And so words aren't quite my forte, so forgive me if I use the wrong words at the wrong time. And lastly, I'll talk about leading innovation, or how I think it helps for people in a leadership position to encourage innovation, what attitudes and behaviours could be useful. Now, to remind you I'm a practitioner, at the background of most of my slides are one of my projects, or projects I was involved with from when I first joined Arup in 1981 to the current day, roughly one a year. So in terms of the context of innovation, for me, it's actually quite tricky, I think, in the building industry. So I'm a structural engineer in the construction industry. Buildings have multiple stakeholders, and none of the stakeholders that we respond to are often the ones that count. They all have different perspectives. We very rarely talk to the people who are going to occupy our buildings, certainly at the briefing stage when we're designing them, or the people who are going to impact in the city, the public. Instead, we're briefed by developers who commission a building, often in a hurry, and try and vacate the territory as soon as possible thereafter. Sorry, apologies to any developers in the audience. The result of this is that everybody has a different idea as to what the risks are and what the benefits might be, and therefore the attitude from designers tends to be conservative, because that's the only way to satisfy all these different people with their different views and perspectives. And almost everybody that I've met thinks that innovation is inherently risky. And I used to work, as some others in the audience did, with a gentleman called Peter Rice, a famous engineer at Arup. And Peter, partly I suspect with his Irish gift of talking, managed to persuade his clients sometimes that innovation was less risky, because if you only did what you did the day before every day, you get slipshod and make mistakes. Whereas if you have to think everything out from scratch, as you have to do when you innovate, then you get it right. I don't quite agree with Peter, but it was an interesting proposition. So even within the profession, as a structural engineer, there are also things, I think, which get in the way of innovation. The first one, to my mind, is absolutely ridiculous if you pause and consider it, that we get paid for service, not performance. It doesn't matter what we do as long as it doesn't fall over. That's the only performance measure that is brought to bear routinely on structural engineers. And the next one is there's no tolerance for failure. The public will not have it if buildings start falling down or bridges start falling over. And therefore, you want to be a fair way away from that potential risk. The public, I think, expect us to be able to work everything out. It's mathematical, it's numerical, it's engineering, it's a science almost, I think, to most people. And yet, of course, that's not the case at all. In fact, what we choose to calculate, and more particularly, therefore, what we choose not to calculate, has an awful bearing on the result. And, of course, all the assumptions you make in your calculations can throw things out completely. So I don't think that the public's expectations are correct. And so, again, we end up as a profession, in my view, as conservative and risk-averse. And ultimately, there's sort of very little reason for change because concrete and steel have now been in our main materials when we timber for centuries. Concrete maybe for 1 century and steel for a century. And gravity's the same, wind's the same. Despite climate change, I don't think everything's going to change dramatically from a structural engineering perspective. However, some things, I think, are going to help us in innovation. So, for me, the impact of IT, I was very lucky, I think, or fortunate to join the workforce in engineering just as computers began to bite. So I feel as I've surfed the IT wave the whole of my time in Arup. And I think that we haven't yet seen the magnitude of the impact it's going to have. I think it's going to change the whole way the built environment is planned, designed, procured, constructed and operated, and with some feedback, I think, from one to the other. So I see all these stages. We have virtual design. We do have virtual design already. And the manufacturing industry, of course, has had it for a long time. But for buildings, every building has been its own prototype up until recently. Only recently have we been able to virtually prototype a building before constructing it. We'll have manufacturing techniques will come to the construction industry. It won't just be sloppy wet trades on site. We'll actually bring components that fit together, hopefully, in a trusted way, and we'll be able to assemble them on site. We can manage our assets by knowing we have predictions of how they should perform before we begin. So we can work out how they should perform when they actually do and compare the two and get feedback from that. Smart infrastructure, smart grids, smart transport. I'm not quite sure what smart water is, but I'm sure it exists or will exist as somebody works it out. So all this, that's sort of optimising the built environment in its use, if you like. And then there's behaviour. We can impact people's behaviour. We can make them use the built environment more efficiently if they have real-time pertinent information as to what's happening. And then we get feedback. We can measure all of this. Data mining is a big thing now. How do we get to understand how people use the built environment, therefore plan and design a better built environment? So why innovate in the end? And I'm just going to bring it down to one thing. I mean, there are many reasons, but this one I think is the most compelling for me at least. It's simply that at the moment with 6.5 billion people we consume more than the planet can provide. And by 2050 we have to add roughly another 50% of the population, and we have to reduce our consumption by 33% or 40% overall. So that's about 100% reduction per head. And then if you go to equity and all the other things, you can realise it's a massive mountain that we're facing, and we can only get there by doing things differently. This is the way that we look at sustainability in Arup, or one way. This is our spear diagram, where we earnestly try and look at every sector and segment of what we're doing in natural resources, environment, society, and economic impacts. And we assess them all and try and work out whether we're doing a better thing or a worse thing by, trades, if you like, between the different segments. You can't always improve everything all at once. However, almost all those things we're measuring are costs. Even the social side, we talk about social impacts of our development, not social benefits. And I don't think there's much point in doing anything if we're not trying to improve people's lives at the same time. So my view, I guess, is that we should move sustainability on a bit and look as much at the benefits as the costs and think about the value we provided. I've occasionally argued that the Centre Pompidou in Paris is a sustainable building, despite the fact that I'm sure its mechanical systems are not very efficient, because the number of people who visit it is more than Notre Dame, the Louvre and the Eiffel Tower added together every year. So simply because of the benefit it is providing to the Paris population, I would argue it's sustainable. And the last one, though, is the most important again for me, is somehow sustainability is wedded to the environmental movement. And somehow the population sees the need for a sustainable future, the need that they have to live a different life and to give things up. You know, to take it to extremes that everybody has to wear a hair shirt to be good in the future. Now, I don't think that's true at all, but I think we, the engineers and the planners, are not yet able to describe a compelling, desirable, sustainable future for people to believe in and want to belong to. And I think that's a work outstanding for all of us to try and wrestle with. So this is from the World Wildlife Fund, who are sort of the big promoters of ecological footprinting. And this is from a report actually a few years ago now, their 2003 report, I think. But it makes my point for me, if you like. They're saying here that on the bottom axis, that's the ecological footprint per person, and obviously we need to get below the planet's capacity, which is around 2.1, or was then, they're saying margin for error about 1.9. But you also need to measure the Human Development Index. You need to have a place where people want to live and where society and civilization can develop. So of all the countries they've plotted there are lots that have a low ecological footprint, and there are lots that have a high Human Development Index. But there's only one country in the whole world, and it hasn't changed, the current report says the same thing, where you get both. But actually, that's the only place we can afford to be, in that top right-hand corner. And this is the way that Arup might look at it. These are our work from our Foresight and Innovation team, showing the 4 plausible futures and asking the question, which one do we want? And you can see there again, planetary health can be dealt with in 2 different ways. What we call carbon is crime, or as Peter Head has wonderfully put to the whole world, the ecological age. And of course the ecological age is the one we want, the one where people also enjoy living, as well as having a planet that survives. So in my way of looking at it, the simplicity, and I do tend to reduce things to their sort of simplest level, is that sustainable development could simply be called delightful efficiency, where delightful is a proxy for everything we're trying to do to make people's lives better, and efficiency is a proxy for reducing all the costs. And the costs, of course, include finance, time, quality, or the reverse of quality. You know, all those things you normally think about, and of course, energy. I've added another one there, which of course is the decarbonising of energy, which you could argue is not to do with delight or efficiency, but is absolutely necessary. So a little bit about creative people, the characteristics of creative people, very short. These I got from a Spanish artist who addressed us in Madrid, and she gave me the first 3. And I thought the first one was the most interesting one, that creative people need to want to be creative. That's their first characteristic, which is actually quite profound if you think about it. The second one, and you've got to imagine a Spanish artist speaking here, that they have to have an independent spirit, which again I agree with to some extent, although in our business it's all about collaboration as well. So there's this balance of personal and independence and being part of a team. Third one is they have to have a degree of self-confidence, and the architects in the room I'm sure will understand that. Silence. Anyway. And the reason is you have to believe that what you do is better than what other people would have done given the same project, if you like. So there's a degree of self-confidence if you're going to do something new. And I've added the 4th point, that I think you also need a supportive environment. It's quite difficult to be creative. You can either do it independently, totally, but if you're in an organisation, then the organisation has to support that. These ones I've taken from a totally different source. This is from a lecturer at the London Business School who wrote a book called Clever. And he was talking about clever people, but I say it applies as well to creative people. But I have one big difference with this gentleman, Rob Goffey, because he thinks that in any organisation there are clever people who need to be treated differently to the rest of the organisation. See, my view is that everybody in the organisation should be treated as though they're clever or creative. And these characteristics are less sceptical, and I think that is absolutely true in my own experience. They're also easily bored. That's sort of a classical view, I think, of creative people, but it's probably true. Third one, though, is not normally espoused as a characteristic. They want to feel loved. They need love. They need reassurance a lot. They hate management, if it's called management, and I'll come on to that a bit later. But they don't mind being led, provided they respect their leaders. And the reason for that respect can be almost anything, according to Rob, and I sort of agree. His example is, if my leader plays a good jazz saxophone in a band on Friday night, that might be enough to have respect, my respect, and therefore I don't mind being led. In other words, it might not be material to the actual thing you're being led to do, but it's still there. And for me, this is the bit about management I think that's important. That you try and keep within an organisation the rules to be as minimal and simple and what is sometimes called manifestly good. That is, that people understand why they're being asked to follow a rule. They can immediately understand the purpose of that rule or that regulation. If they can't understand the purpose, it is probably better not to have the rule, not to have the efficiency that you think might come from the rule, because the demotivation that comes from telling people to do something when they don't understand what the benefit of doing it is probably more powerful. So I'm now going to talk to you a little bit about Arup from my perspective. And there are people, this is a terrifying topic for me to do this evening because there are people in this room who understand Arup far more than I do, who've been here far longer. There are several ex-chairmen in the room. So I'm probably going to get it wrong, but bear with me, it's my story tonight. Arup studied philosophy before engineering, and to me I think that's quite important. So I think he thought as much about people and the human condition as he did about making things stand up. He started as a contractor. My shorthand says that during the war, when he came to Britain, he was born in Britain, but he studied on the continent and started his career on the continent. But when he came to Britain during the Second World War, he got frustrated by the British bureaucrats who wouldn't really give enough credence to his ideas for deep water ports, for example, or more efficient air raid shelters, as another example, and founded Arup as a firm of consulting engineers, perhaps he thought a more respectable profession. And I can see Jack's looking at me in amazement, because this is obviously not quite the story that he understands, but never mind. And founded Arup Consulting Engineers in 1946. The wonderful thing about that is he was already over 50 when he founded the firm. And I think most people over 50 are probably looking forward to the golf and doing less, not starting all over again. And the purpose of the firm was to get engineers, architects and builders to talk together. Because in his view in those days, in a fairly stuffy London, let's say, the architects designed things, they passed it to the engineers to size them, who passed it to the builders to build them. And there wasn't an awful lot of interaction along the way. It was very clear, that the hierarchy, if you like, of the process. And we always say that the first project, the London Zoo Penguin Pool, is a classic example. It couldn't have been conceived by an architect alone without speaking to an engineer, and an engineer may not have dared put it forward without a contractor who's prepared to build it. The one bit I always find curious, though, is according to my references, it was built 10 years before Arup & Partners was started, even though it's our first job. But that's part of what happens in places. The other thing that Ove did, or Ove and his partners did, is that they decided at a certain point to give up their ownership in the firm, to donate the firm to a charitable trust, which now owns the organisation in favour of all the employees. So we have no owners, we have no shareholders, we've decided to have no debt, and therefore we can remain totally independent and do what we want. And I think this helps in the context of innovation, because it means we can always provide our own risk assessment of what we do. We never have to assure anybody else, if you like, apart from our clients and the regulators. But generally, we decide what will work, what won't work. We decide whether an innovation is appropriate or not appropriate. He also set down the key thing in a way. About 20 years ago, maybe 15 years ago, I used to worry a lot about what it was that Arup did, or more particularly what it was that Arup didn't do. If we were all the owners and the members, and we were then 8,000, now 10,000 disparate people, how do we remain in one organisation? What stopped us just going off and doing tons of different things and not being connected? And again, Ove had this sorted out in the 60s originally, but written down in 1971, was he set down in what we now call the key speech, what are the Arup core values? What is it that we are doing? And I think his reason for doing this is down in the bottom right-hand corner, under what's called results, is he said there must be a way to work and be happy or to be satisfied with what you do. And if we pursue the aims in the top left-hand corner, and I won't go through them all, we should be able to find a reasonable set of people who can be happy pursuing those aims. The interesting thing is we've never really sought out, I don't think, people who follow those aims, not in any rigorous way. We assume when people come in the door that they're reasonable and therefore they'll support those aims, if you see what I mean. And if they're totally unreasonable and don't like them, that they might leave. It's quite strange to me to think that we've gone from 0 to 10,000 people in such a mildly ad hoc fashion, but we have. So on top of those aims, a sort of a culture has developed for Arup. And it's, now this is not something that's written down, I don't think. It's just something that has developed over time. And the first one is a sort of, if you like, a laissez-faire or Liberty Hall attitude to life, which is get good people and let them do what they want. It's probably the most important aspect. The second is to try and have a flat organisation. And as you get larger, that becomes increasingly difficult. I think for some reason, bureaucracy breeds. You know, it's a bit like mushrooms. You put them in somewhere dark and they grow. What comes with that is an inability to direct. So it's a very difficult organisation to control in any way. But instead, you get the motivation from people, from their independence of action, which I think outweighs the inefficiency of an inability to direct. In fact, it's more powerful than that. You're harnessing all 10,000 people's view of what should be done, rather than it being effectively a solitary person at the head of the organisation determining what should be done. So in that sort of idea of a chaotic, almost anarchic organisation, how do we go in the right direction? You know, how do we decide what it is, what innovations we should be doing or what innovations we shouldn't be doing? There are a couple of methods I think I can see. So research is one. So we decided recently to do most of our research in collaboration with others, which obviously helps in terms of meeting people, in terms of getting other people's input and networking generally. But it's most importantly, it's now coordinated by Jeremy Watson. And it's set down through a research roadmap. So we actually put together a document that suggests which issues we think in the short, medium and long term are the issues we should be looking at for our future. And we also recently have set up an organisation called the Arup University, which is coordinated by Faith Wainwright, who's also here this evening. And there are 3 levels to this. The professional modules are sort of the basic training or education, if you like, that graduate engineers and or consultants or architects or whatever they may be need to become professionally qualified, to become chartered. We also have doctorates for individuals who are lucky enough to find a research topic that they can pursue at work. But in the middle is the more important one, these what we call master's modules. These are 1 or 2 week residential intensive courses with pre-work and post-work for between 12 and 20 people. But the point is we can choose the topics that we're going to run master's courses on in any given year and run a couple of them and then move on. And what you manufacture, if you like, is a cohort of experts in whatever that subject is, who then go back around the Arup world and take that forward. So this is a way of steering the organisation in certain directions. So now as the middle part of my talk, I'll talk to you about a project. So a complete change of tone. I'm sure you're all bored to death with words. And now we'll start looking at some real work. But just to acknowledge that this is a collaborative project. In fact, the most important thing about the Water Cube is the number of people who contributed on a roughly equal footing. So there is nobody can claim that they are the author of this work, unusually perhaps. There's no individual who will say, I designed the Water Cube. Instead, it was a profound collaboration between Australian and Chinese architects, engineers and contractors. It was an international design competition of 10 teams from around the world for 10 weeks. And what we did at the very beginning of it was actually put the whole team together. And that sounds easy, but it actually doesn't happen very often. So we had all the different disciplines of engineering in the room on day one. And some of them you normally only employ a specialist later, when all the thinking supposedly has been done and you know the idea. And to give you some examples of that, the mechanical engineers, on the very first day, before anything had been drawn, said that the Water Cube is an issue of heating. We've got an average temperature in Beijing of 15 degrees, and the leisure water part of the swimming centre at least needs to run at 28 degrees. So it's a heating issue above all else, and the most efficient way of heating something is to build a greenhouse. So that was an idea, a concept that was put there from a mechanical engineering point of view before anybody started drawing or sketching or designing in its normal phrase, normal interpretation. And the lighting guy said, yeah, that greenhouse works for us as long as you diffuse the light. Direct light's a problem with glare, but we'll diffuse light, no problem at all. The most profound input came from a source who often wouldn't even be present at that stage of design, I think, which is the acousticians. Because they said noise is a real problem in swimming pools. This is the Sydney Olympic Aquatic Centre. Because a lot of people are having fun, they shout and scream, and they splash, and they jump. And water is a reflective surface, and the tiled surround you tend to end up with for hygiene reasons is also a reflective surface. So if, for example, you made your greenhouse out of glass, another reflective surface, the noise would become almost unbearable, and it would be quite difficult to deal with. So it was actually the acoustician said there's this stuff called ETFE, as used at the Eden Centre in Cornwall, that lets sound through. It is not reflective, it is largely transmissive. It actually reflects very high frequencies, but only a small amount. So the idea of ETFE as a material came from the acousticians. And it would not have arrived at all if they hadn't been in the room on the very first day. And then as a structural engineer, we didn't have much to say at all. Structural engineering in a lot of ways can be quite dull, I think. So without a form to think about, we simply said, well, there is a corrosion issue. If we have a steel structure, we don't really want it in the pool hall because chlorine, which is used to disinfect the pool water, in the atmosphere becomes hydrochloric acid and is quite aggressive, very aggressive. We also didn't think external steelwork in Beijing context was necessarily the right thing. In fact, the bird's nest next door, of course, has a lot of external steelwork and it's working quite well. But at the time we said no. But architects also approach things from different perspectives. And so the planners, if you like, or the program architects, as the Americans would call them, started working on how to lay this thing out. What is it we needed? What do we want? And again, our experience of previous Olympic aquatic centres said the Olympics is one thing, but the long-term life of the facility is far more important. And therefore, we want to maximise the future activity in the swimming centre, and therefore the leisure water, as it's called in the trade, needs to be maximised. We want the biggest leisure centre possible within the footprint of the site. And that's actually why the building is square, because we had a square site and we want to maximise its footprint. Very simple. The urban planners had a look at the map of Beijing. And this is from Google Earth, and at the bottom, the yellow square is the Forbidden City, the cultural centre of Beijing. And traditionally, the cultural axis of a Chinese city is north-south, although the modern development is all happening on the east-west axis, largely out to the east. But the Olympic Green, amazingly, is only 7 kilometres north of the Forbidden City and straddles, if you like, that important cultural axis. And the plan that they had adopted had the stadium, the circular mark there, and the swimming centre, the square, either side as the gateway to the Olympic precinct. And beyond that, you went into urban parkland, and beyond that into rural land. So it was an incredibly important composition to get those two buildings that led from the city and its cultural heart through to the countryside outside Beijing. Meanwhile, the designers, if you like, the design architects, they were obsessed by ideas of water. They wanted a physical manifestation of water in what the swimming centre would look like. But actually, they'd polarised a bit. The Chinese architects were interested in iceberg forms and eroded shapes. And the Australian architects were interested in wave forms, surf and breaking waves and things like that. And so we weren't getting very far, to be honest, 4 weeks into the design competition until this was published, which of course is now the well-known bird's nest with our neighbour. So we had no idea until then what would be on the other side of the boulevard. And this beautiful, round, sculptured, sexy, if you like, shape was published. And it was but the work of an instant to say, well, there's his red and round, we'll do a blue square. Okay? We'll do a blue box. And everybody latched onto it because we started finding it actually meant something. And again, it's a backwards justification to some extent, because red is male and blue is female in Chinese culture. Circles speak of the heavens and squares of the earth, and if you look at Chinese traditional planning, it's made largely of squares but occasionally circles, and so on. So, and yin and yang, male, female, the whole thing, and one's external as well. The bird's nest is much more about an external form. The water cube is an introverted internal form. So we all agreed, and suddenly all these ideas about it being an insulated greenhouse, in fact, we'd worked out by then, because we didn't want to let the heat out again, using ETFE, and lastly, having the structure in a cavity became good because it wasn't inside, it wasn't outside, but also to insulate the box, we needed 2 layers of ETFE. So we had a gap between them. So then we looked at the structure. And I can't remember why I had this thought, but it was, if the structure is the only thing in the cavity, how does it want to be in the cavity? How does structure want to inhabit space? Not a question that engineers often ask themselves, I don't think. And certainly when I looked at structural engineering and references on the web, and this is the first reference to IT and its benefit, is knowledge. You can get whatever you want now very quickly from the World Wide Web. So I did research on structural engineering and how structure wants to inhabit space and didn't get anywhere. Then I saw this photograph, and I thought, well, there you go, there's the answer. That looks like structure inhabiting space. I wonder what it is. Or more particularly, I wonder what its geometry was. And went off and did some more research. And I found it's a fascinating topic. It's a topic that lots of people have contributed to. So here we have Lord Kelvin in the 1890s posing, how do you subdivide three-dimensional space in the most efficient way? And his own answer is in front of you, the Kelvin foam. And in fact, none of his peers at the time could do better than the Kelvin foam, and it stood as the most efficient way of subdividing three-dimensional space for a century. Meanwhile, a Belgian physicist, Plato, was looking at soap bubbles. And he had decided that soap bubbles tended to come together 3 films at a time on a line, each film at 120 degrees, one to the other, and the lines come together at the so-called tetrahedral angle of 104.9 something something, forget the rest of it. But anyway, the equal angle that you can subtend a solid with. But he couldn't prove it. It was purely a matter of observation. And the reason these two I'm putting next to each other is, in my view, an infinite array of perfect soap bubbles will also be the answer to Lord Kelvin's conundrum, because the surface tension of the soap film will try and minimise the amount of surface area between the bubbles, which will mean it's the most efficient way of subdividing three-dimensional space. And then I found out that an Irish physicist, Denis Ware, had come up with a better solution than Kelvin in about 1993. So almost exactly 100 years later, he came up with something that was 2% more efficient, called the Ware-Phelan foam. And it has 2 different polygons, slightly more sophisticated, made of hexagons and pentagons, more likely to produce that 120-degree angle and 104-degree angle that I referred to earlier. And I found out that if you put a lot of Ware-Phelan foam together, and I could do this because Professor Ware had published all his work for anybody else to use. The geometry of the Ware-Phelan foam was in the public domain, not a piece of IP locked up for his future, commercial benefit. And I pinched his molecule and extended it. And you see, this is a CAD view, plan, top left, an elevation, bottom left, the other elevation, bottom right, and an isometric view on the top right. But more importantly, if you cut an arbitrary slice of this absolutely infinitely repeating foam, you end up with what you see in front of you, which has an absolutely random pattern on its surface. So you start with something completely repetitive and you end up with something totally random. And I met Denis Ware later, who forgave me for nicking all his geometry. And he told me, he looked at me straight and he said, "Tristram, were you so ill-educated that you didn't know that the easiest way to get a random pattern in dimension n is to start with a regular one in dimension n+1? So there you go. That's my teaching for you all this evening. And unfortunately, he even gave me a book in which it was written. But for me, it was a breakthrough, because we could start with something totally regular that we could make and understand, and we could end up with this beautiful random pattern for the ETFE pillows on the outside. So if you go through the same process, the Ware-Phelan foam, but use the lines as structure, you end up with a piece of structure that looks like this, but is made out of completely repeating elements and repeating nodes or connectors. And if you compare that structure, although only a thin piece of it, to the original photograph that set me off on that journey, you can see there's quite a lot of similarity. And in fact, I was originally taken by the idea this was some organic product. It was obviously some cellular thing that I was trying to imitate. Actually, it's a piece of polyurethane foam under an electron microscope. But there you go. That's why the bubbles are relevant. It's all part of the same issue. So to make the water cube, we start with this big block of the Ware Phelan foam in the top left-hand corner. And we cut out a slice 20 metres tall. That's the top right. Middle right, we end up with, we've got our slice. Left on the middle, you cut out a 200-metre square blob of it on plan. And then along the bottom, you hollow out the rooms. And there are only 3 rooms in the water cube. And therefore, the whole of the structure is contiguous along the walls, across the roof, and down the internal partitions. And it looks something like this. And this was 2003, June 2003. And there are 24,000 elements joined together at 12,000 nodes. And it's all very well me telling you that they repeat in geometrical terms. The CAD programs of the day didn't understand that they were repetitive and drew each one as a unique entity. And of course, our PCs at the time started falling over. This was somewhat more complicated than what then things, and now it's easy, but then it was quite difficult. We decided also that the only way to try and convince the judges that our idea had merit was to make a physical model. It was actually a requirement of the brief anyway, but we wanted the physical model to be accurate. So we actually used rapid prototyping, first time I'd become involved with it, to make a physical model from the CAD model. So again, the IT revolution, the ability to transform your virtual model into a physical model without doing anything. Supposedly without doing anything. It took me 4 weeks to get the data into a certain format that would work with the machine, because they've never made something which had that many component parts. Normally they make one object that's very complex. They don't make 24,000 objects that are joined together, but we got there with 1 day to spare. This is it coming out of the modelling environment. I think this is also interesting. It's made out of epoxy, and an ultraviolet laser fixes the epoxy in 1.1 millimetre thick layers, increments, and then the platen on which the model sits drops inside the liquid epoxy, and it does it again. And they're fearful of breaking the structure as they drag it through the liquid when it's only partially made. So the machine adds all this scaffolding to the structure that's made. So they didn't trust my structure to work. They added an awful lot more, which then had to be cut off to make it work. But never mind, it got done. So that was what we sent to the judges, and we won, which I'll never quite be sure whether we won on merit or not, because actually the Chinese had already decided that CSCEC were going to build the swimming pool and they were part of our team. But never mind. I hope we won on merit. And then we had to justify it then to a learned panel in China, which was quite hard work. 7 days of every day explaining things and them asking questions, and then every night trying to work out the answers to the new questions that they were going to ask the next day. And it wasn't helped by my Chinese colleague engineer saying, surely a 120-metre span should only be done with a truss, as his opening remark. But we won the job, and we came back to Sydney. We built the analytical model that I showed in front of you, and we now had the first major hiccup, because it didn't stand up. In all our excitement of how to convey it to the judges and in enthusiasm for our idea, we hadn't actually checked that it worked, which is sort of a minor oversight, perhaps. So we then had to invent a whole new computer process of selecting the size of the elements. The reason I couldn't make it stand up is I simply didn't know which elements should be big and which ones small. And if you made them all too big, it was too heavy. And if you made them all too small, it was too weak. But we found actually an iterative analytical technique whereby you start everything off tiny, analyse it, everything that's overstressed you make a little bit bigger, and anything that's understressed you make a little bit smaller, and continue this process, converged in 25 cycles on a model that did work. And there are only 10 different sizes in the model in front of you, each one a different colour. And you may get some idea now why I couldn't guess which one went where. Right? And in fact, this is only one solution. The thing is so indeterminate. There are millions of possible solutions. But to get through the Chinese regulatory process, we had to have one single elastic solution that complied with all their codes. So we had to find one suitable answer. And I quite like the idea the computer has decided which ones are big and which ones are little. And when you run it the next day, it decides something totally different. But it doesn't matter. Any of them will work. Any of them do work. This is also, I think, a fascinating thing. It turns out that I will claim, and nobody I think can necessarily prove me wrong, that it's the world's most seismic resistant building. And as we had these earthquakes later in Sichuan, it was obviously quite important. And one of the reasons is these are the first 4 principal modes of vibration. They all have roughly the same frequency, and the 2 laterals and the torsional use almost every single element in the structure as part of its resistance path, and each one of those elements can form a plastic hinge at each of 2 ends. And so you have to deploy roughly 48,000 plastic hinges before you collapse the building. And in fact, a full or 1/3 scale non-linear static pushover of one piece of wall, physical, showed it will take at least 100% gravity laterally and still stand up as a structure. Might be coincidence, it might be because it's a natural geometry, if you like. It's a different thing to what we normally come up with. The next analytical challenge was the joints. All these 24,000 elements, which all have the same geometry, are now all different sizes. And so actually each joint, even though it has a shared geometry, is unique. 12,000 unique joints. To make fabrication simple, we decided to use a simple spherical connector. This is something that the Chinese is a common technique, so this is appropriate for its context. It's also simple because you can just square cut the ends of the tubes, as long as the ball you choose is large enough. But you cannot justify that ball very easily, except by detailed finite element analysis, as you see in front of you. So we took a fairly radical approach of saying if all the balls are selected with an algorithm, which uses a similar set of rules depending on the size of the elements which have all been computer chosen to be appropriate coming into it, and if we do finite element analyses on 10 of them, and they all work, then so will the other 11,990. And believe it or not, we persuaded the Chinese regulatory authorities or the expert panel that was correct, although they did insist that we then do subsequent testing to show it was a ductile failure if we got a failure. So not just the finite element work, but also backed up by physical testing. All of this then, so the computer has determined the size of the elements, the computer has also decided which size of node to use, and then all that information can simply be moved back into the CAD package as the construction information. And the job is done. And by the end of our design process, we could move walls around or add doors or do anything to the main structure, which we did often, and have a whole set of construction drawings a week later. And this is in 2003 using ordinary PCs, not using supercomputers. So for us, it was a breakthrough in technology because we got to a sort of hands-off approach. You could also then convey that in any way you wanted. So we could produce wireframe models with databases and tags of all the information, or you can produce conventional 2-dimensional construction drawings. Or you can just give the 3-dimensional model to the contractor. Because they were all the same thing, or different views of the same thing, they were absolutely coherent one with another. You can also visualize it. This is actually just a way of looking at the construction information. This isn't the usual architectural render done with a bit of Photoshop. This is a pure view of the construction drawings. I put this in just to sort of remember to say it's not always all smooth sailing. ETFE, I became increasingly worried about it. We had, for a technical reason, which I won't go into because it's quite complicated, the roof was dead flat, right? And it's 200 metres square. And it's going to collect a lot of rain and maybe some hail. And snow, indeed, in Beijing. So I became worried about what would happen if an ETFE pillow inverted, if it lost its pressure and went upside down. And you know, I think you get about 30 tonnes of water in one pillow before it would break. And then land on somebody. Luckily, it would actually land on the next set of pillows, but might land on somebody eventually. And so I got nervous to the point where I said, why don't we make the roof out of glass? Let's do little glass domes. They're probably cheaper than ETFE, which was not a product that you could then purchase in China. And they're more robust. And I persuaded all our team this was a good idea. But when we first won the competition, we went to visit the Central Planning Committee of China, who do their first planning permission right at the very beginning of the concept. For 2 days, there were 40 of us and 40 of them sitting across the table, one from another, and asking formal questions and getting formal responses. And a typical question would be, have you considered the acoustics of the swimming pool enclosure? And the answer would be, we are considering the acoustics of the swimming pool enclosure. Okay, and then we move on to the next one. And this went on for 2 whole days until the very last question, from the Central Planning Committee was, this ETFE material, does it look like plastic? This is the first time we weren't quite sure how to answer, so there was consternation and lots of muttering amongst our ranks. And eventually our representative stood up and said, ETFE is plastic, and so no doubt it looks like plastic. Okay. And sat down. Now there's consternation on the other side of the table, the first bit of life we've seen for 2 days. And eventually they say, we will need to consider whether the National Swimming Centre of China should look like plastic. And that was the very end of the planning committee, and we heard nothing. You don't actually get planning permission in China, but nobody said stop. So we carried on. And then when I eventually said I wanted to do this in glass, and we persuaded the architects and we persuaded the project managers, it went all the way up, and then a message came down saying, no, the mayor has approved plastic, and it will be made of plastic. So that was it. But the flat roof is a problem from a drainage point of view. We have a network of gutters around each and every pillar. The pillars are up to 9 metres across. And so drainage was an issue, but what we did is find places where we could penetrate the steel node with a downpipe and then put in a siphonic system inside the roof cavity with 220 outlets above it, and justified again that 50% of those outlets could be blocked and it would still do the job. Because it was dead flat, the good news is the water can go always 2 ways to find an outlet. It's never directed in any particular way. The fire engineering was probably the toughest of the lot, and this is probably where I was at fault. During the competition stage, I had asked our best fire engineer in Sydney, is fire a problem with swimming pools? And she blithely answered no and gone on holiday. And then she came back from holiday to find we'd won this competition, and she had thought I meant a sort of domestic scale swimming pool. Well, I'd asked the question. So she found something which didn't comply with any single aspect of the Chinese fire regulations. It didn't comply from an egress point of view, the smoke control systems didn't comply, the compartments were too large, the structure had no fire rating, the facade was combustible, and we didn't have sprinklers. Generally, we did put a few in the end. So that was a major issue, particularly because the Chinese don't even recognise performance-based fire engineering as a profession at that time. But we did, using our Mandarin-speaking fire engineers in Hong Kong, persuade them in time that it was justifiable. Although that had its own problems. We demonstrated that a fire at the top of the grandstand, might heat up a little bit of steel. But just to be on the safe side, we showed that if we lost 40 square metres of steel, it became, a dead weight with no structure. Because of this amazing indeterminacy to the structure, it would still stand up. Whereupon the same expert panel turned around to our team designing the CCTV tower and asked whether they could cut a 40-metre hole in that. And would it still work? So you've got to be a little bit careful. But anyway, the reason it works is partly because ETFE is a godsend in a fire, rather, even though it's combustible. It tends to vent, form a hole, let the smoke out, and if you like, it runs away from the fire, and it doesn't support flame if the flame is extinguished. It itself will not support it, and you don't get burning droplets of plastic coming down inside. And indeed, Ian Liddell knows far more about this than I do, but it is used regularly in places like shopping centres where you actually use a hot wire to remove the ETFE panel in terms of fire to vent the smoke and justify that piece of the shopping centre as being an external environment, not an internal one. This is the way we wanted to construct it, if you like, with an Australian or an English perspective. That is, if you make these jack elements, four prongs, and have a bolter connection at mid-splice, the geometry of those jacks are identical, repetitive, and then on site you just bolt them together, and you get what you want. The Chinese, though, of course, it's a different thing. Labour is cheap, mechanisation is expensive, making all those extra joints would be time-consuming for them, and so instead they simply brought to site lots of tubes, lots of spheres, they made a full scaffolding, and they welded it together. And they continue to do so. And I, to this day, have no idea whether the tubes and the balls are in the right place. But as I said earlier, it actually doesn't matter too much. The right amount of steel is there, and it's all interconnected. But it was quite an undertaking. And then eventually we got to see what it would look like when they took the scaffold out. It takes a long time. It took a long time to build. Longer, I think, than they anticipated. And you can see there that wear feel and foam, that the erratic geometry, or irregular, but made of repetitive pieces. The ETFE, I think, is also one of the most interesting parts, and this is the bit I get most pleasure from, because we covered it with an array of silver dots to reflect the heat and light. And this was to give us diffuse light, as I said at the beginning, but also to control the heat gain for different spaces. So while the leisure centre wanted to be heated, because the water body mass would absorb the heat, in an area like a cafe, you begin to cook. So there you put on lots of silver dots. So each pillow is tuned to its own thing. And what you get then is this, you can see through some of it, but not all of it. And in fact, as the sun moves round and reflects on it in different ways, it changes its characteristic completely. As the sun comes round obliquely, it becomes opaque. And when the sun's behind you, it turns into a completely metallic surface. And that's simply because now all you can see is the dots. You can see them doing their job of reflecting the heat and light out of the pool. On Australia Day, 26th of January 2008, was the official opening, and we were given notice the Friday before, and it was a Monday morning, that we could come and see the official opening if we wished. Fortunately, I was in Hong Kong at the time and managed to get there. And this was the first time we'd seen the inside, because when they took the scaffolding down, they had also put all the ETFE up, but they were now doing all the finishing trades, and it was full of 4,000 workers and smoke and dust, and you could get no idea really what it was like until we walked in there. And I must say I was bowled over by, that's only 5% light getting into the competition pool hall, because the television companies demanded it was as low as it could be so they could control the environment with artificial lights. So there's only 5% light getting in there, but it still felt different to something that's opaque. It felt like natural light. There's a different quality, I think, to natural light. As I said, cafes, this is it's almost a reflective place. Could be a church in some ways. It's almost spiritual. And I still hold that the reason that 40 world records were broken in the swimming in Beijing is actually because of the quality of the space that people were performing in, not because their swimsuits were special. And now, lastly, this is just this year, this is the leisure centre, the most important part, has now been finished and kitted out. And that, we didn't see that at all because it wasn't complete during the Olympics. It's actually just one part of the building that was never shown. And this gives me even greater pleasure, because this is what it was about in our minds when we were designing it. It was letting the light and the heat into this space and making it joyful. And there it is at dark at night with its neighbour, the bird's nest. I think they make an awesome gateway to the Olympic site, and it's all the other buildings, a lot of which are very remarkable, good buildings in their own right, you almost ignore because of the two at the front door. That's what we submitted for the competition. That's what we set out to build. If you like, a box of bubbles clad in pillows of ETFE, and that's what we actually built. And I've never, before or since, worked on a project where the idea is so enclosed, if you like, or so complete at the competition stage that it doesn't change. The next 5 years was simply enacting that idea, putting it into place. So, the last bit of my presentation this evening, back to the words, not just the pictures. This is, I think, 10 years ago I was asked to talk about design and how you design. And I sort of stood there and said, I don't know, it's just what I do, or what I have done. In the last 10 years I've been asked that several times, so I'm trying to consider, to think about what I do, or what people do, what I see people do. And so this is the approach, I think, that I would recommend. The first one is simply that you can design everything. Everything that we do can be done better, and you can do it deliberately. And it does apply to everything. It's not just physical objects, it's processes, ideas. Whatever it is that you do can be done better. Second one is to start with the widest possible view, to think about all the ramifications of what it is you're trying to do. Do not try and design something generally in isolation. Third one, as I talked about earlier, is aim to improve people's lives. Think about the consequences of what you're doing from a human perspective. The two before, efficiency and delight, and then of course you have to deliver the solution itself. It's no good if it just stops at the end of design. For a physical object at least, you have to enact it. This one, though, is an issue in our organisation. I don't know whether it is in others. Because design is an intensely personal thing, and that was that thing earlier about having an independent spirit, the risk here, I put it, is designers will design for themselves. What I mean by that is when faced with a new thing to design, a new challenge, the last thing a designer tends to do is ask for help. Because it's a bit like being given a crossword puzzle. You don't immediately ask everybody else in the room to give you the answers. It's the satisfaction of solving that problem yourself is part of what wakes you up in the morning. But what I'm trying to do is persuade people that you can still get that satisfaction, even more satisfaction, if you start by researching what others have done in the same space. Start with what are the existing solutions, what are the known potential things, but then do better. Your challenge is now greater because you set yourself a bar to do better than, rather than going off like a squirrel with nuts on the first place. But it's a very difficult thing to actually get people to do. Their tendency is to take the challenge and do it on their own. So, step by step, understand what it is you've been asked to do. We're really weak at this in our organisation. Do we go and talk to our client and actually ask them what they want? If they've sent us a brief, no, we probably just take the brief. We've done a hotel before, we've done a stadium before, whatever it is, just get on with it. But that's a mistake. The first thing you should do is find out exactly what it is that client wants, what's important to them. Learn what others have done, as I've just said. Try and find the best solution. Use both sides of your brain. I like this. Design is one of the few activities that we ever do where you use both logic and intuition simultaneously. So I like that. Exercising both sides of your brain. I like that idea. This is one I think I do, but I don't do it deliberately, but I've read books that say you should, is once you've tried to come up with a really good solution, put the whole problem away. Stop working at it and put it away. Put it into the background, do something else for a while. And allow your subconscious to assist you with coming up with solutions that you wouldn't otherwise do. Another book I've read says that when you wake up in the morning is when your brain is most plastic and most likely to make unusual connections. And certainly I'm a POM living in a hot climate in Sydney, but I still have a bath every morning. I think it's actually because those are the 20 minutes where I think before you start the day. You end up very hot and sweaty, which isn't always very good, but never mind. And the last one is that innovation doesn't always happen. And I say rarely on command. You cannot force yourself to innovate. All you can do is set the environment in which it may occur. It may not. Last few slides, leading innovation. Tolerance. You won't get innovation unless you can tolerate failure. And of course this is difficult in the physical world, as I was talking about earlier. But the virtual world now allows this to happen. So we can tolerate failure of ideas in a way, provided somebody's making sure you pick them up before they become real. They're all obvious, these things, by the way. Well, I'm not claiming any personal credit for them, but they are, on reflection, what I think are important. Delegation, don't be the bottleneck. Let others get on with the job, right? But then keep an eye. You're a bit like the sweeper in a football team. You pick up the bits at the back, the ones that get through. Lack of control is good. Can't persuade most of my colleagues of that one, but I'm convinced of it. Encourage informal networks. You do not have to know everything that's going on. In fact, it's probably better if you don't. More things will happen if you don't know about them. Trusting people, probably the most important. Consulting widely, yet still if you're the leader, you still have to make the decisions. Trust people until they become untrustworthy. That's so difficult. What tends to happen, I see, is that when something goes wrong in an organisation, a rule is put in place to make sure it won't happen again, rather than going to talk to the person who's broken trust and try and sort it out. And then the last one for me, again, is treating everyone fairly. And this is to do with, as I said earlier, for me, everybody is clever. You just have to find out how and why they're clever, what they can do, and harness it. Obvious, but very weak in our organisation, again, is dealing with poor performance. We tend to think it's a good thing to give people, it's tolerant, if you like, to allow poor performance to continue. But of course its impact is on everybody else. And it's unfair in a lot of ways. And lastly, this slide, which is how you behave. Increasingly we sit behind our computers, even so-called designers. You design on a computer and you deal with email. People don't know who you are, you don't know who they are. You don't know what they can do, you don't know what they can't do. And lastly, it doesn't really matter who you are or how you lead, provided you do it sort of honestly and transparently, I think. And that's the end of my address. Thank you very much.
I'm sure we have time for questions. I'm sure there are people who would like to ask you questions. Who would like to start? There's always a moment at the start.
There is, isn't there?
Yes, please. Yeah.
Thank you. Nigel Whitehead, a Fellow of the Academy. You summarised clearly the design intent and the design process. Could you talk to us briefly about how you considered maintenance philosophy as part of the design of the cube?
Good question. And it was considered. It perhaps wasn't the leading idea generator, if you like, but it was certainly considered. ETFE, we're not sure of its life expectancy. It's been around, NASA invented it, I think, in the 60s, and used it in space. It's been used in buildings since about the early to mid-80s. There's no degradation that we're aware of. It's a highly bonded polymer. It's related to Teflon, which is non-stick because of all its bonds, if you like. ETFE is also largely non-stick. So it's got a long life. The steelwork is all protected from the environment because it's inside this hot, dry cavity as part of the heating mechanism, if you like. So it's pretty well protected. And again, we've got ETFE on the inside, protecting it from the pool hall environment. So largely, the building doesn't need much maintenance. In terms of repair, there are walkways on all those gutters I showed you. So you can walk all over the roof, and you can abseil down the sides, and ETFE can be patched if it gets a hole, for example. We also have a 3-metre wide moat all the way around the perimeter because it doesn't take kindly to cigarettes or knives. So we keep the people and the ETFE separated.
Yes, please.
I'm interested
To the microphone.
I'm interested in the diffusion of light and obviously eliminating solar gains and allowing light through. But you said that you only allowed 5% of the light through. When I saw the beginning of just before the Olympic Games, the weather there was pretty miserable. It was overcast and grey. I mean, does that mean that for a lot of the time it's really too dark inside?
Not that I've seen it. And the 5% light transmission is the competition pool hall only. The leisure centre is around 25%, or a bit more, or more like 30%. So each space, as I said, is slightly different. But 5%, if I'm right, I think it's 5, 10, 20, 40, 80. So it's about 4 stops on a camera. Now, if you imagine, as you move from different conditions, you're often moving your camera around far more than that. So it's not, 5% of natural light is still a lot of light, if you like, compared to any artificial environment.
Scott.
Thank you, Scott Steedman. Thank you very much, marvellous lecture. On your right, Robert, are some copies of Ingenia on the table in which the water cube is described. So if anybody in the room wants to see that, it's there. Coming back to your philosophy of design at the outset in innovation, you pointed out the big issue that we have in this area, that we're paid for service, not performance. Do you think there's a model for innovation that would reward performance and not service, and would that lead to some transformation in the way we do our engineering?
I have to say yes. I think, however, yes and no. Yes to the second part of your question. I think it would be transformative. I think the issue, certainly in the buildings world, is finding a model that people trust, because the benchmarks against which you can measure performance are very few and far between, partly because, as I said earlier, each building is its own prototype, or has been, through history, and therefore it's hard to find the benchmark. In the more industrial areas, or even in infrastructure, it's an easier proposition because the design ambition is more readily stated. For example, an oil rig, it might be getting first oil or 40,000 barrels a day, or whatever it is, on this date. It's quite a simple measure of success. In buildings, it's a tougher one, but I'm beginning to think the way around it is to buy into the success of the whole project. So, for example, you could be paid according to the value of the building and or its rental ability, if it was development, speculative development, relative to the market at the time. So you don't want to buy into the ups and downs of the commercial market, but if you could buy into how your building performs or what it's worth compared to others, then yes. But I think it has to be something as basic as that, as a way of getting clear measurement.
Paul Brewers.
I was a fellow of this academy. Where did the architect begin and end, and where did you begin and end? What was the interaction with the architect, or wasn't there an architect?
No, there's definitely an architect. PTW Architects in Australia, CCDI in China, and we worked as a team and all together right from the beginning. As I said, the planning of the building, urban design, what it looks like, very much is part of the architecture. But we were more integrated than I've ever experienced before, the engineers and the architects. And the nice thing is we agree that we were, all of us, and we all claim credit to have designed it equally. Okay? And that's one of the things actually I didn't talk about. If I could just digress a moment. One of the issues sometimes with design is that everybody wants to feel that they played a large part in the idea or the design that's produced. And the other people then start saying, no, you didn't have that idea, or you didn't design that bit, I did. And I think we've somehow got to get rid of that idea that it was either person A or person B. Actually, the whole team designs it. And it's very hard sometimes to unravel exactly who said what when and how things emerge, because they come up, and they might come up to several people simultaneously, actually, some ideas. And so we must become more generous in allowing everybody to take the credit for designing something, not exclusively.
Yes, question there.
Do
you want to use the microphone?
I probably don't need that. With the massive expansion of the mining industry in Queensland and other places, oil industry, mining industry, are you involved in any projects there so that the new plants are not only efficient, but they're nice to look at as well?
That's a very good question. Actually, we're not much involved with the resources sector in Australia, but I've often wondered when I go to an airport why the domestic passenger terminal has to be a modern cathedral, and the hangars next door and the maintenance facilities can look like whatever they want to look like. It's a slight puzzle, although things are changing. The world of bridges, I think, is changing dramatically. The infrastructure world generally, people care now what their roads look like, what their bridges look like, what the lamp standards and all the bits that make up the urban environment look like. We've still got a way to go, but we're getting there.
Another one over there.
Duncan Leach from BMJ Architects. At the beginning of your presentation, you talked about the hindrances to innovation, risk aversion being one of them. On the water cube, you're light years beyond the boundaries of BBA certificates and the like. Did you find it was very difficult to get the suppliers to actually buy into providing warranties, etc., that your PI insurers would be happy with, etc.?
Yes, very good question. The primary regulatory environment was sort of the building regs, if you like, and getting the structural approved, the fire engineering approved, and that sort of thing. That was enormously helped by the Mayor of Beijing committing to starting on site in December of 2003, only 6 months after we were awarded design contracts. So basically the regulators were told they had to you can't start without permission, and you have to go through the regulations on the way. And therefore the regulators were told they had to give us permission by that date, or be answerable to the mayor. Now that was obviously quite a good incentive, if you like, for us to have good conversations. But largely we did it by complying with the regulations. So from a structural point of view, it fully complies with the Chinese Steel Code, for example. Downstream is more difficult. One of the stipulations from a political point of view was that every product in the water cube should be available to be made in China. The only exception made was the ETFE film itself, which was imported, but all the fabrication of it and the extrusions and all the erection of it was all Chinese. And we actually had to change the whole pool filtration system to a sort of a sand-based technology, because that's all that was available from Chinese suppliers. So that kept us inside, I think, a regulatory environment, if you like, that the Chinese were comfortable with.
Yes, please. Ian. Do you want to use the microphone? It's being recorded, so it's good to have that.
Ian Little. I think there's an awful kind of hype about we must innovate. I mean, why innovate? Actually, it's much better to do things the way you did them last time, but a little bit better. And actually, in your building, as you said, you haven't really used materials any different to the way it's been used before. You know, the ETFE technology was fairly well established by then. Steel and welding to balls was quite well established. All the basic sort of ingredients were well tried and tested, which is good. Because if you're using new materials in a new way, then you can definitely run into trouble. So, yeah, I think what you've done is a brilliant piece of design. And in a way, all buildings, all new buildings that are a bit different have elements of innovation. But in building industry, we go in small steps, step by step, which is very good.
Well, I'm the same as you, Ian, and when I said at the beginning, I tend to creativity, design and innovation are slightly interchangeable to me, which probably means I'm ignoring the real step change innovation, which I haven't seen in the building industry since I've been in it.
Yes, question at the back.
It's Greg Atwood. As graduate structural engineers, we're taught not to be over-reliant on computer analysis and indeed not to trust anything from a computer unless you can approximate it by hand. With this structure, you seem to almost place blind faith in analysis. How did you get yourself comfortable with that?
The simple answer is that we analyse it using 3 different codes and building 3 separate models independently. So that's the actual procedural answer, if you like, to your question. But I disagree with the opening statement. I am quite comfortable with computers finding answers, provided you play with them. I think that's ultimately what you must do, and see the consequence of your playing and understand it. So you may not understand the numbers, but you can see what happens if I change this or change that, and you can believe that the computer is behaving the way you'd expect it to. So for me, one of the things I didn't talk about is increasingly I now use the computer to come up with ideas, to explore ideas of structures that may or may not work, or that may or may not be efficient. But let's just have a go, as opposed to the idea that the computer proves something that you've fully comprehended yourself before you begin. So I say a formal answer to your question, but also I would challenge the premise that you started with.
Yes.
Neil Collins. In the UK, we have the building code and all sorts of a plethora of other regulations. Do you think that these are part of the solution or part of the problem?
Okay, well, I'll try not to venture into the UK system, partly because I don't fully understand it and partly for fear of offending somebody. But I sit in Sydney in New South Wales in Australia, and the regulatory environment is actually different in each state. And the most benign one is the New South Wales one, where there is no need for me to submit calculations to anyone. I simply say, I have designed it and I am a practicing structural engineer. I need no qualifications. I need no registration. I need nothing. In Singapore, where I also practice quite a lot, is a heavily regulated environment where I have to have an independent checker and a building control authority, both of whom will review all the calculations in detail and have their own views as to what is prudent or otherwise, regardless of what the on top of the regulations, if you like. I have not observed that structures are any safer in Singapore than they are in New South Wales.
That stunned everybody. Yes, Philip.
I'm Philip Greenish from the Academy staff. I was very interested in what you said about sustainability and your definition of it, which you described very broadly as including benefits and improving people's lives. And of course, often this will come with a cost. When you're providing a service to clients, which include hard-strapped governments, penny-pinching businesses, how do you persuade them of the same ethos?
I think, okay, but again, some of that premise I won't accept. There is a commonly held view that sustainability costs money. That is, that making something more energy efficient, which is what normally people are referring to, it means adding devices, or what can sometimes be called green bling, to a building. Actually, it doesn't have to be done that way. You can simply make your building more efficient. In other words, you can reduce things and get more efficiency and better performance rather than adding things. And sometimes we have to think about it that way. But your specific question was about providing more amenity for people, or delight, or whatever. And again, I think there it's just a matter of understanding what your client wants. So it's not something you can do independently of your client necessarily. Although we did have a discussion recently about the moral stance you should or shouldn't take if your client wants to design something that's ugly. And architects indeed meet this more often than engineers do, but I think engineers are analogous ones to that. You know, if your client wants you to do something that makes the built environment less efficient, is that, you know, do you have a moral position on that? So my view is I'm optimistic that you can normally do it all. You can normally make something more beautiful, better amenity, cheaper and more efficient. You've just got to work out how. And it might be incrementally, as Ian says.
Yes, question in the front row here.
Tom Smith Fellow, and also consulting engineer, long since passed out of functional work. I belong to an organisation called Steenson Varming, and we have been associated with Arup for many, many, many years. The one aspect of the life that I have led, which you describe in your little leaflet here, is the reference to being beautiful. Mm-hmm. In other words, the aesthetics of buildings. Now, you described, Tristram, every other control that you administered in the building. How did you control, if you did control or influence, the aesthetic quality of the building?
I didn't. Well, I might have done, but not directly, because that's the architect's role, generally, on a building job, and I would never deign to suggest to an architect what something should look like. But I care what it looks like, and I care that in the eyes of my architect and in their judgment it is beautiful. And I think that's what we can bring, is to be sympathetic to that aim and not naturally antagonistic to it.
Yes, question here. Just on the second row. Just second row here, yeah.
Jane Werner, Cummelso Fellow. I very much enjoyed your talk and agreed with a great deal of it. And I agree with what Ian said about innovation is in a way not the right thing we're striving for. It's kind of creativity and bringing about the best solutions. I just, you know, the Grand Projet is, of course, fantastic, and you get this chance to explore all sorts of things. I just wonder what your attitude is about the minuscule projects and how you bring creativity to those.
Yeah, good question, Jane, and the answer has to be why not? It's just the same at a different scale. Of course, it's not quite like that because the time you can afford to put into a smaller project is less. The last slide, though, before this one, was actually my own house, for example. So I made sure one project at least was a modest scale, and we've just finished actually a sandstone sculpture in the Botanic Gardens in Sydney, which is a delightful project. How to make an arbitrary shape out of sandstone blocks in a way that, and again, using modern IT, cutting the blocks directly from three-dimensional models and so on. So I think a lot of the things can be brought. It's still delightful efficiency, whether it's done at this scale, in my view, or that scale.
Jeremy, and then after that.
Listen, I think we both agree it's really important to bring the next generation of designers and engineers through following the best principles. I wonder what your views were on the best way of forming the next generation of engineers and designers in your footsteps.
I don't know, well, I wouldn't say necessarily they should be in my footsteps. That would be the first answer. At the beginning, though, Robert said I'm also a graduate of Cambridge University, and I've had long debates with Sir Duncan Michael, who's unfortunately not with us this evening, but he would hold that Leeds University, for example, gave you a far better education in engineering than Cambridge did. And I was never going to contradict that, but I reckon that the Cambridge sort of lack of education, in some ways, taught you to think, as opposed to know anything. And for me, that's worked better. in my life, I think. So for me, yes, I have to comply with regulations, but I don't start by thinking about the regulations. I start by thinking about what might work and then how it fits into the regulations, if you like. So my plea would be, in this time of increasingly adding to engineering syllabuses, occupational health and safety and quality control and environmental management systems and how to run a practice and how to send invoices and so on and so forth, all of which are things you have to know. But please make sure we keep time for teaching people to think or giving them the opportunity to think. So I think that would be my single answer, is making space in the modern syllabus for people to be creative.
Music to our ears. Now, there was a question there, I think.
Peter Fagg.
Yeah.
Firstly, which was the country that met both of your requirements on the graph? Was it Costa Rica?
I don't actually know. It's a short answer. You're quite correct there. From the colours, it was South American. My assumption actually is it's Brazil, because of their fuel, sugarcane-based fuel cycle because the largest part of the ecological footprint is actually carbon dioxide absorption, and if you can reduce your emissions, you're a long way in the right direction.
The second part was completely different. Did you find any difficulties reconciling your own personal values, Arup's corporate values, and the Chinese contractors' values? Because I know personally, working with contractors, my values clash completely, but what did you find?
Okay, the first two is an easy answer. Again, I think a speech by Duncan Michael says that we take on graduates and then we tell them what Arup is about. We don't actually. We assume they find out what Arup's about. And then if they don't agree with it, they leave. Actually, what happens in my own personal view and what happened to me is I didn't really have any full set of values when I joined Arup straight from university. And my values have become Arup's values. In other words, I am Arup and Arup is me in a funny way. So no conflict at all in the first two. And even with the Chinese contractor, no, I don't think so. The wonderful thing actually about putting up, if you like, a slightly courageous project is people either buy into it or they don't. But once they've bought into it, and the Chinese more than most, they're incredibly enthusiastic about trying to make it work and make it happen. So there's this initial hurdle you have to get over to persuade people it's credible. But again, the Chinese, when they think that they're doing something new and different, even if only modestly different, Ian, become very enthusiastic about doing it. So the contractor was very much on side in trying to achieve everything we set out to do.
Are there any more questions? Yes, Phil Bruce.
I'm sorry to come in again. It's such a fascinating lecture, and you seem to have lived your life the other way round to Ove. I mean, you started an engineer, you've ended up as a philosopher. So I'm going to ask a very general question. Very early on, you talked about the characteristics of Arup's no shareholders, a very flat structure. It has been my observation recently that our classic corporate structure, capitalist structure with shareholders, is breaking down rather seriously. And I can think of other companies that are very successful in the similar structure, such as Bosch. It's a privately owned private company still, really, no shareholders. None of that pressure coming from the media and the markets and everything. And would you just like to expand on that, and whether, particularly when you're in a creative situation, isn't it much better to have this structure of yours?
Well, the problem that, you're sort of preaching to the converted in a way. Yes, it's the short answer. From my perspective, it is entirely better. For all those reasons you've just enunciated. It's to be able to do what you want to do and to act in your client's interests without outside influence on you. It's as simple as that, and I think that is completely liberating. However, it's not completely without its issues, of course. Not everybody always agrees with it. It's not very easy to take decisive action within Arup for the reasons I enunciated. We grow by natural means, and people come and join us, and we continue to grow. But of course, we all know that you cannot grow forever, ever. So what's the end game? How does it work in the future? And if everybody like me joins the company as a graduate and stays for the whole of their life, what shape does the organisation become, and is that credible? And you can go on with the potential issues that come with it, but in answer to your first question, absolutely yes from my perspective. But don't forget, I went from the ivory tower of Cambridge to the ivory tower of Arup without a single seat, in a seamless jump, and I have no idea what the rest of the world is like.
Yes, the question there, in the back.
Yeah, just following on from that question, I suppose, which is, I suppose the counter-argument to that would be that the shareholders or an external force would give you a kind of more market-driven view of what you have to provide. What stops what you produce in Arup and the innovation that you do just becoming fad or whimsy?
Two things, I guess. The first one was in the middle of the value set, which is we have to remain solvent and we have to remain in business. So what we produce has to be of worth to clients. They have to continue to buy our services. So that's one answer. The second answer is my observation of Arup over time is that the building engineers, like me, are a little bit introverted. And we tend to do what we want and hope that there are people out there who will buy it, if you like. A bit like an artist, we want to be in control of the creative process. The infrastructure engineers, though, are more pragmatic and more hard-nosed, and delivery is important to them, and they will say that they do what their clients want. They are client-focused. They're a service industry, if you like, which some of us more dilettante people sort of react to rather negatively. But more recently, our planners and people who join the firm are interested in sustainability and the future of the built environment are motivated not by doing what they want or what their clients want, but what they think the world needs. And I think that's quite profound, that change in our organisation. It's coming from the bottom, if you like, of the organisation upwards, the more recent people who've joined us. And all those things are possible when you don't have shareholders. But unless you can show why doing what the world needs makes more money, it's a difficult change to make when you're beholden to the market. So, in a way, we can respond to the labour market, if you like, as well as the capital market.
Yes, please.
Stuart Lipton, the world is risk averse. What price risk?
I think the cheeky answer to that, Stuart, is don't tell everybody. And it won't get priced. But the real answer, I don't know. That's not my forte, I think. I came back from designing the Sydney football stadium. No, hold on. Sorry. I came back from my first trip to Sydney, having worked on the Sydney football stadium roof, which is one of the first sort of lattice tubular cantilever sort of cable stay, but not. It's used tubes. And one of the first questions I was asked by one of my more academic colleagues was, what did you do about fatigue? And the answer was, well, I thought about it and didn't think it was an issue. Which is a trivial answer, but it's sort of what I'm talking about, which is risk management, I think, in structural engineering is a lot about the thoughts and the processes and the way you attack things from different directions, more than filling in the tables and making sure you've written it all down and given it a red or a green or a yellow thing and exactly identified the size of the risk and what the consequences of the risk are and therefore whether you're going to address it or not. Even though I think that's an important profession, doing risk management. It's slightly different. I'm not answering this well, so I'll stop now.
Well, Tristram, you've answered many, many questions very well. We have a drinks reception waiting for us. I think we've heard a wonderful lecture on all sorts of aspects of creativity and design, and some words absolutely ring in my mind, because just a week or so ago at Cambridge we had a Chinese delegation, and they at one point in the proceedings they asked me, how do you get top class world research happening at Cambridge? And I said something very similar to what we've heard Tristram saying. I said, get good people and let them do what they want. And I think that's absolutely been illustrated tonight in a wonderful way by Tristram, describing to us all the qualities needed for creativity, innovation, and I'd like you to join me in expressing our appreciation. Thank you, Tristram.